Hello children, today we are going to discuss about electric field lines. We have already discussed about what is electric field. The region surrounding an electric charge is called electric field. These field lines have very important properties which we are going to discuss today. So, electric field lines, do they really exist? The answer is no. They are imaginary lines. Okay. So when there is a charge, there is field everywhere. Surrounding the charge, there will be field everywhere. But field lines are drawn for our understanding and convenience. We draw lines like this. Here, everywhere. We are drawing lines. Does that mean that this region doesn't have field? No. There is field there also. Electric field is present everywhere. Okay. Surrounding the charge, electric field exists. For our understanding, we are drawing imaginary lines. So, electric field lines are imaginary lines. The field lines are imaginary, but the field actually exists. That you should understand. Field exists. Okay. Field exists, whereas field lines are imaginary lines. So, now to find out the direction of electric field at any point, you have to draw a tangent. See here, you can see a tangent drawn. This tangent will indicate the electric field at this point. Similarly, here if you want to, you will draw a tangent here. At any point when you draw the tangent, you will understand the direction of the electric field. Okay. So this is a sample representation of diagram showing the electric field lines. How this is drawn, we will be seeing later on. So, as you can see here, this we saw in the previous class also. So, here you can see a positive charge. The field lines are emerging outwards in the outward direction. And here there is a negative charge and the field lines are moving inwards towards the charge. For positive charge, it is moving away from the charge. So, with this, we understand the first property. Electric field lines emerge out from a positive charge and flow inwards towards a negative charge. Okay. This is very important. Field lines move away from a positive charge and it move towards a negative charge. Now you take a system of like charges, two like charges. Here I have taken positive. Even if it is negative, they will repel away. They will move away from each other. The field lines will not move close to each other. They will be repelling each other and they will move away. So similarly here also you can see here, this is a negative charge. Here also repulsion is happening. They don't allow the field lines of one negative charge will not allow the field lines of another negative charge to come closer to each other. Okay, they are repelling away. Now we will take a combination of one positive charge and one negative charge. This type of arrangement is called electric dipole, which you will study in the next class. As of now, electric dipole is a system of two equal and unlike charges. As you have seen from the first property or the previous property, field lines are starting from the positive charge and they are ending in the negative charge. Okay, all the field lines, if you see, they are starting from the positive charge and ending in the negative charge. So this is another important property. Electric field lines start from positive charge and end in negative charge. Start from positive charge and end in negative charge. Another important property is, you can see here, these field lines do not form any closed loop. What is a closed loop? A closed loop is one that starts and ends in the same point. There is no closed loop here. They are starting from the positive charge and they are ending in the negative charge. This is not a loop, right? So field lines do not form closed loops. And also another important thing is, The field lines do not cross each other. No field lines will cross each other. No two field lines will cross each other. What can be the reason? See, for example, I will draw one field line this side, another field line this way. They are crossing each other. You take this as assumption. Now, when I draw a tangent here, I will get one direction here, another direction here. Can the electric field at a single point have two directions? No, right? So, there cannot be two directions for electric field at a single point. That is the reason no two field lines will intersect each other. 2 points to remember here. One is electric field lines do not form any closed loop. Other one is electric field lines never intersect each other. And the reason for not getting intersected each other is if they intersect each other, they will show two different directions for electric field at a single point, which is wrong. Okay. And once again, if you see near the charge, if you see the field lines near the charge, they are crowded, right? There are so many field lines. As you go farther, the number of field lines per unit area is lesser compared to that it is closer to the closer to the charge. So the field lines get crowded near the charges. That indicates that there is strong electric field in that region. The number of field lines are less per unit area. That means the field is, the charge is away from the area where you are checking the electric field. And if the field lines are crowded, that means there is strong electric field in that region. And electric field lines are continuous curves. There will not be any breaks in between or discontinuity. You can see they are continuous curves. They are like now coming towards the negative charge continuously. They'll start from the positive charge and they will end in the negative charge. Okay. So here we have summarized all the properties of electric field lines. They start from positive charge and end in negative charge. They do not form closed loops. They never intersect each other. So, and the reason why they don't intersect each other, and about the strong and weak field region, and they take continuous curves. Please go through this so that you get a clear understanding of the properties of electric field lines. So now, with the understanding of how to draw electric field lines, let us discuss few questions. Why the direction of an electric field is taken outward for a positive charge and inward for a negative charge? See, if you take a unit positive charge, you always draw the field lines outwards. That is the convention. Okay. So, and similarly for a negative charge, it is drawn inwards. Sorry, it is drawn inwards. Okay. The direction of the field will be shown inwards. So, direction of electric field is same as that of force lines. Okay. So, for the force, for a positive charge will be directed outwards, and for a negative charge it will be directed inwards. So that similar way we are drawing the lines for electric field also. Do electric field lines of force really exist? What is about the field they represent? So do they exist? We have already discussed, no, they don't exist. They are imaginary lines to represent the presence of an electric field there. But they represent the presence of electric field which is actually existing, which is real. So the field they represent is real, but the lines of force is imaginary. Clear? I hope this is clear. Please read through, you will understand. And draw lines of force to represent the uniform electric field. For uniform electric field, you have to draw like equidistant. Equidistance means the distance between two lines should be equal in all the cases. Okay, all these should be equal. So equidistant parallel lines you have to draw to represent uniform electric field. See here, these type of diagrammatic questions are very important. Please listen. Figure shows electric lines of force due to point charges Q1 and Q2 placed at points A and B respectively. That is, there are two charges Q1 and Q2 placed at points A and B. Write the nature of the charge. So as you can remember from the property, So field lines move away from positive charge and move towards negative charge. Here you can see that the direction arrow is indicating inward direction. That means they are moving towards the negative charge. Q1 is negative. Similarly, Q2 is also having field lines directed inwards, right? So Q2 is also negative. So Q1 and Q2 are negative. Q2 is also negative. Okay. Shall we move on to the next question? Okay. A positive charge plus Q is kept in the vicinity of an uncharged conducting plate. So there is a uncharged conducting plate. Uncharged means there is no charge. Okay. And there is a positive charge plus Q placed in the vicinity. Vicinity means neighborhood. So you have to sketch the electric field. So when this is plus charge, what charges will be induced in the plate? Very good. It should be negative charge. Right? So now how to sketch the field lines? Field lines will start from positive charge and they'll end in negative charge. So this way you have to draw the diagram. And this will be the diagrammatic representation for this question. Okay, so this is the like diagram. Okay, I hope this is clear. Two large metal plates, P1 and P2, tightly held against each other. So there are two plates. One plate is P1, another plate is P2. They are held towards each other and placed between two equal and unlike point charges. So here you can take plus Q, here you can take minus Q. Point charges perpendicular to the line joining them. So this is the direction of the line joining them, so that the perpendicular direction will be this side. What will happen to the plates when they are released? So here see children, positive charge. So what will be induced here? Negative. Right. Here it will be positive because this charge is negative. So obviously what will happen? There will be a attraction between the charge and the induced charge of the plate, so that the plates will move little bit apart. And as you drew earlier, you have to draw the field line. So here from positive to negative, and here it will be this direction. Here it will be outward. Here it will be inward. So we'll see the diagram. See, you can see here, there is a small spacing because of the strong attractive force between this charge and this plate, and also this charge and this plate and this charge. Okay. So the field lines you have to draw using the properties. So consider the situation shown here. This is a very interesting question. What are the signs of Q1 and Q2? If the lines are drawn in proportion to the charge, what is the ratio of Q1 and Q2? First, let us solve the first part. Sign of Q1 and Q2. Here if you see Q2, field lines are all directed radially outwards. That means Q2 is positive. Q1 is, for Q1 it is moving towards Q1, right? Q1 is negative. Ratio of Q1 is to Q2. How will you find out? Q1 by Q2. Check the number of field lines that are emerging from are directed towards Q1. Q1 you can see these are the lines 1, 2, 3, 4, 5, 6. So Q1 by Q2 is equal to 6 by, here Q2 if you take 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So 6 by 18, that is 1 by 3. Okay, so the answer will be 1 by 3 or 1:3. Ratio of Q1 and Q2. So these type of questions you have to understand by based on the field lines you have to do the calculation. Okay. Next question will be, for a point charge, the graph between electric field and distance, electric field versus distance. You know that E is equal to 1 by 4 pi epsilon naught Q by r square, right? So distance E is proportional to 1 by r square. So among this, which will represent 1 by r square? Exactly, this is the graph. Okay. So as E increases, R will increase in a squared manner. Okay, so this will be the diagram. This graph is available in your textbook also. You can go through. Electric field lines provide information about field strength, yes. Field direction, yes. Nature of charge, yes. Then the answer should be all of these. Which of the following figure represent the electric field lines due to a single negative charge? This is wrong because field line should be directed inwards. This is correct. Field lines are directed inwards. This represents uniform electric field and they are directed outwards. Same way this also outwards. So the answer will be B. I hope this class was interesting, useful and understandable to you. If you have any doubts, please raise in the comment section. I will be happy to help you. Thank you.